Okay, so after a little bit of algebra, here we are. So you got a chance to practice that. Let's move on to a more complicated example. So then if we've got y equals root x over 1 plus 2x, then our top function, I'm going to rewrite in exponential notation. X to the 1/2 over 1 plus 2x. So before we start all this, do we all know pretty quickly what the derivative of x to the 1/2 is? Okay, so you all said the derivative of x to the 1/2 is 1/2 x to the minus 1/2. And if you had to write it in radical notation, you'd be writing it like that. Okay, so here's y. What is the derivative of y with respect to x? Well, it's a quotient rule. Draw a line and down below, denominator squared will go. Okay, what goes on the top? Low, 1 plus 2x, d high, 1/2 x to the minus 1/2, less high, x to the 1/2, d low. Derivative of the denominator is just 2. Hey, when you get a question like this and you have to simplify it, then all of that work we did in the beginning of the year with factoring out these exponents of the lowest the variable with the lowest degree will help you here. Okay, so here's our denominator, 1 plus 2x, all squared. And we've got a GCF. We're going to factor out the GCF of 1/2 x to the minus 1/2. It goes into here, 1 plus 2x times. How many times does it go into here? If I factored out a 1/2, then it goes into 2 4 times. If I factored out an x to the minus 1/2, it goes into here x times. Just check. 1/2 times 4 is giving me 2. X to the minus 1/2 times x to the power of 1. The bases are the same and you're multiplying. Add the exponents. 1 plus minus 1/2 gives it to me. Okay, then let's just simplify these brackets, collect like terms. Negative exponents go into the denominator. A fraction on the top puts a 2 in the denominator. Okay, so I've got 2x minus 4x gives me negative 2x, 1 minus 2x on the top, and I've got 2x to the 1/2 times 1 plus 2x all squared on the bottom.